Today, we're basically becoming architects, but we're not designing buildings. Nope, we're designing the invisible structures that hold our entire digital world together. We're talking about data, and we're going to uncover the special kind of blueprint that makes it all work.
Just think about any app you use every day. Spotify, your banking app, whatever. Behind that clean, simple screen, there is a massive, tangled web of data. You've got users, projects, departments, dates, you name it. So how in the world does the app know that this employee works in that department on that project? Well, that's the big puzzle we're solving today.
He can't just dump all that information into a digital bucket and hope for the best. That'd be chaos. No, you need a plan. You need a detailed blueprint that shows exactly where every single piece of information goes and, crucially, how it connects to everything else. In the world of data, we call this blueprint a conceptual model.
So what does one of these digital blueprints actually look like? Well, in this first part, we're going to get our hands on the main tool that data architects use to draw them up. It's called the Entity Relationship Model, and it's pretty much the language they all speak.
This whole process, it has a name, conceptual design. And there are two really important words here, high-level and independent. This means we're not thinking about code or what kind of software we're going to use yet. Not at all. This is all about sketching out the big ideas on a whiteboard first, getting the logic right before a single line of code ever gets written.
And when it comes to this kind of high-level design, there's one undisputed champion, the Entity Relationship Model, or as everyone calls it, the ER model. If you're building a database from scratch, this is almost certainly where you're going to start.
To really get what the ER model is all about, it actually helps to think back to like middle school grammar class. Seriously, we're going to break our data down into its basic parts of speech, the nouns and the adjectives.
First up, let's talk about the nouns. In our data world, we call these entities. An entity is just any thing or concept we want to store information about. An employee, a project, a department, these are the main subjects of our data sentences. They're the main characters in our story. So if entities are our nouns, then attributes are our adjectives. Simple as that. They are the descriptive details that give our nouns some flavor. An employee isn't just the label, they have a name, a social security number, an address, a salary. These attributes are what make our data rich and meaningful.
But, it gets a little more interesting than that. Not all adjectives are created equal. An attribute can be simple, like sex, it's just one single value. Or it can be composite, which means it's actually made up of smaller parts. Think about name, which is really a first name, a middle initial, and a last name. And finally, it can be multi-valued, like, say, previous degrees, where one person can have several different degrees we need to list.
And this right here is a perfect visual of a composite attribute. Just look at address. It's not just one big chunk of text, right? It's broken down into a street address, a city, a state, and a zip. And you can see street address is even broken down further. This kind of hierarchy is absolutely essential for making the data searchable and useful later on.
Okay, so we've got our nouns, the entities, and we've got our adjectives, the attributes. But right now they're just kind of floating around, not connected to anything. The real magic, the thing that makes it all work, is how we connect them. And for that, we need verbs.
A relationship is the verb of our data model. It's the action word that links our nouns together. An employee works on a project. An employee manages a department. These connections, these verbs, are what turn a bunch of static lists into a dynamic, living system.
Now, to actually read these blueprints, you have to know the symbols. Think of this as our legend. It's pretty straightforward. The rectangles are our entities, the nouns. The ovals are the attributes, the adjectives. And, most importantly, those diamonds represent the relationships, the verbs that connect everything. Let's see how this all works in practice.
All right, enough theory. Let's make this real. We're going to design a database completely from scratch for a fictional company. Let's get to it.
Okay, so every design starts with a list of requirements. Here's our mission. We need to keep track of departments, projects, and employees. And there's some specific rules. An employee can only work for one department, but they can work on many different projects. We also need to know which department controls which projects, and we have to track an employee's dependents. That's the goal.
So step one is finding all the nouns and adjectives. Based on our requirements, we can pretty easily pick out our main entities: department, project, employee, and dependent. And for each one, we list its attributes. But as you can see here, right now they're just 4 separate islands of information. They aren't talking to each other at all.
And now for the best part. We add the verbs, the relationships, and just like that, everything clicks into place. You see how adding those diamond shapes, works for, manages, works on, connects everything, our separate islands are now one cohesive system. We can see exactly how an employee relates to a department, how departments relate to projects, everything. This is our final data blueprint.
But a truly great blueprint isn't just about drawing lines between boxes. It needs to have rules. In data modeling, we call these rules constraints, and they're what make sure our digital model accurately reflects how things work in the real world.
The most important rule is something called the cardinality ratio. I know, it sounds a little intimidating, but it's really just a fancy way of asking one simple question. How many? For example, how many departments can one employee manage? Just one or many? How many employees can work on one project? These how many rules define the connection, whether it's one-to-one, one-to-many, or many-to-many.
In this slide shows us exactly what that looks like. Over on the left, you see a many-to-one relationship. You can have many employees all working for one single department. That makes sense. But on the right, it's a many-to-many relationship. Many employees can work on many projects. Any employee can be on multiple projects, and any project can have multiple employees. Getting these rules right is absolutely critical.
Now, we've been focusing on the ER model because it really is the king of database design. But it's not the only blueprint language out there. You might also run into something called UML, which stands for Unified Modeling Language. And as you can see from this table, while ER diagrams are laser-focused on just the data, UML is a bit broader. It's often used for designing entire software systems, not just the database part.
And here, you can see the difference immediately. This is our exact same company database, just drawn in the language of UML. Notice anything missing? Yep. No ovals or diamonds. Instead, everything is in these neat boxes with different sections. It's like a different dialect, a different visual style, but it's telling the same fundamental story about our data.
So what's the big takeaway here? What's the point of all this? It's that designing a database isn't just a technical task of storing stuff. It's really an act of translation. It's about looking at the complex, messy real world with its people and its rules and creating a clean, logical, and accurate model of that world in a digital form.
You know, every app you use is its own little universe, built on a foundation of data. Now that you've seen the architect's blueprint, it kind of makes you think, doesn't it? If you had the tools, what kind of world would you build?